Okay, so hope your ears didn't die. It's 11:20, but whatever. You're given an integer n. Perfectly straight street is represented by a number line ranging from 0 to n minus 1. You are given a 2D integer array lights representing the street lamps on the street. Each light position range indicates that there is a street lamp at position I that lights up area from whatever 0, so something to left and something to right. Brightness is the number that lights it up. Minimum brightness on I. Number of positions on the street that have brightness at least requirements. So what is, first of all, what is the length of the requirement? It's n and n is 10 to 5. Okay. And I'm guessing the range can also be 10 to 5. Of course. Okay. And the requirements are 0 to n minus 1. No, 0, blah blah blah. Okay, and these positions are okay. Okay. Well, of course we can start by brute forcing, and there are multiple ways to brute force this. First way is that we check each lamp if it covers a position. That's of course like n times m, where m is the number of lights, but that is of course too slow. Now, let's say we just mark the area which it covers. That's another way of doing it, and then we just check if the counts at each position are at least the requirement, and count the number of positions that met the requirement. Problem is that doing this is too slow. Like, we have to go through this position plus 1, this plus 1, this plus 1, this plus 1, this plus 1. And that's bad. Is there any way we could mark this entire segment with a constant number of marks? Well, if we put a plus 1 here and a minus 1 at the next position after its end of range, so like for example for green light we put plus 1 at first position and minus 1 at fourth position, and then we make cumulative sum, we get 0 lamps here, 1 lamp here, 1 lamp here, 1 lamp here, 0 lamps here. And we just do this for all lamps, make the cumulative sum, and then each position check if the requirement is satisfied. For each lamp we do O1 work, so that's OM, and then we just go through all positions, and that is n, so that's n plus n. So simple prefix sums task. So lights requirement. So let's make like a prefix of n plus 1. Yeah, and then go through the lights which are vectors, so auto lights, and during compile time I think the compiler fills in the correct type into auto. And now prefix L0 plus plus, prefix L1 plus minus minus. Oh wait, no, we need to calculate light, because we got the position and range, so we take L is max of 0, as exactly in this, and then it's light 0, so So position minus int r is minimum of n minus 1 and light 0 plus light 1 and prefix l plus plus and prefix r plus 1 minus minus. This is gonna be okay because r is gonna be at most n minus 1, so doing r plus 1 is gonna be at most n, which fits in. And now we just go through met r0, so how many positions met the requirements. We go for each position. If I, then prefix I, so we get the previous number, cumulative sums, sometimes called prefix sums. If prefix I larger requirement I, met plus plus, boom. This took 6 minutes. This should be an easy problem. This was extremely easy. Prefix sums. Instead of adding plus 1 to each position in range of lam, add plus 1 at the start of the range of the lam, and minus 1 on the next position on the first position outside the range of the lam. Number of lamps shining, brightness at a position is then sum of prefix until and including that position. Approach. Keep, make a brightness array, and for each lamp on the appropriate places. Then just iterate over the brightness array and calculate cumulative sum and compare it to the requirement. Of n plus n. Since we first mark the range of each of the ON lamps in O1 and then iterate over all position over all ON positions. Space complexity O of n, since we store brightness at each position. Okay, maybe a modification can be that, let's say you get lamps that are, you get queries that maybe lamps get removed or edit, and for that you can, for example, use a segment tree and then do sums on prefix. You can also use FAANG tree for this. That does sums on prefix, but that has some hard math which bit manipulation which I cannot do off the top of my head, but segment tree I can do. And another interesting problem is that maybe if they have varying brightness or you want to count the position which have the queries, like adding, removing lamps, and counting the positions which are meet the requirement. That might be an interesting problem. I think that's still doable with lazy segment 3, but because what if you remove a lamp? Well, then you need to propagate -1 at the start and +1 at the end, and after propagated, you might also need to update, so at each node you store the brightness and how many are there that meet the condition. And if you, let's say you want to make the query, that's interesting problem, but I'm going to sleep, so good night.